Hello, welcome back. I want to show you a few properties of continuity before I start solving the next example. And we know that if you have two functions added or subtracted or multiplied by a scalar or divided by each other, these functions are supposed to be continuous, except check for the quotient, and g, the bottom, should not be equal to g should not be equal to 0 at the limit point. But as I said, multiplication by a scalar, sum or the difference of these functions, and the product of these functions and the quotient are continuous. Polynomials, rational functions, radicals, trigonometric functions, and exponential and logarithmic functions are always continuous in their domains. In this exercise, we have the function sine x minus 8x, and we are going to investigate for continuity. But as you see that this function is the difference of two pieces. One piece is the trigonometric function sine x, and the other piece is a polynomial 8x. As I reminded you earlier, you have the difference of two functions, and we're going to check the continuity of each piece. Well, the first piece is the trig function. As long as we are in the domain of sine x, we're fine. Continuity survives. And remember from the pre-calculus section that sine x has the domain minus infinity and infinity, so it's defined for all real numbers. And same as polynomials, and polynomials are well defined for all x. So, and the domain of 8x is minus infinity, infinity. So in turn, f has the domain minus infinity and infinity, and each piece has the same domain. So, and we know that these two functions are continuous on their domains. So f of x is going to be continuous. So you can see this by graphing them. If you have a TI-84, you have this continuous graph, and I put the x min x max to be negative 0.3 and 0.3. But if you expand that interval, nothing is going to break. So the graph is going to be perfect continuous function. So we use the fact here that trig functions, logarithmic, exponential, radical, rational, and polynomial type functions are always continuous in their domains. All right, that's the end of the video. Thanks for watching. I'll see you in another video. Bye.